Done.
Welcome, everybody. Good morning or good afternoon or good evening, wherever you are. This is the last webinar of the IGAD Coffee Break webinar series. Thank you for joining. You know that you can find all the webinars of the series on YouTube. We will give you the link in the chat so that you can see the whole series. I'm Valeria Pesce. I will be introducing our speaker today. Before introducing the talk, just very quick housekeeping notes. The meeting is being recorded for your information. It will be posted on the RDA YouTube channel. You can raise your hand to ask questions after the presentation, or you can type your questions in the chat box as you prefer. So let me introduce the webinar today. The topic is analysis of time series of Sentinel-1 and Sentinel-2 data, the new quality of information for agriculture. And our presenter is Karel Sharvat. Many of you probably know him. He's been in the RDA community for a long time. Some of us have known him for even longer than before the RDA was established. Karel is from the Czech Republic. He has a degree in theoretical cybernetics. He's a member of the International Society for Precision Agriculture Research, also a member of the Research Data Alliance, of course. He's vice chair of the Club of Ossiak, and most importantly, is also the chair of the working group of the Open Geospatial Consortium on Agriculture. So, Karel, over to you for the presentation. Thank you.
Dear Valeria, thank you for introduction, and I will try to tell you about the work of our group. It is not only my work, but we have a large group dealing with Earth observation, and I will try to tell you something about our experimentation and about our result working with time series of Sentinel-1 and Sentinel-2 data. I am personally working for Earth observation almost all my career. I start to be active in Earth observation in '83, and now in reality I am happy that there are new possibilities on the side of the technology and also some new data. When I started, the first data was there were already used Landsat thematic mapper. We start many years ago with this, but now with new additional data from Copernicus and other commercial data, there are a new possibility to develop new application and to help to agriculture. Today I will be focused mainly on the different method of classification, and I would like to tell you a little about my presentation. At the beginning, I would like shortly present it two organizations which are cooperating about this topic, and then explain why we start work with time series, why Sentinel-1 could be used, show some examples of image classification, object classification, and image segmentation based on the time series. So, the Plan for All organization is relatively young. Yes, at the beginning there were projects. The project Plan for All, it was a European project, and people who know Europe know that we have in Europe Inspire directive, and the goal of this project was to help with building data models for Inspire. Then we start with second project, and after this in 2015, we established this Plan for All with three founders, and the goal was such, yes, what we recognize, I am working long time with European project, but what I am very unhappy that usually after end of the project, the result very often disappear, and nobody is caring about this result, and new projects are usually starting from the scratch, not building on the top of previous project. And this was the goal of Plan for All, to take the previous result and start to build on the top of this and reuse the result and go with a new solution which continue previous research, because some sustainability of research and development I see as the key, and without this it's very difficult to move, and very often I saw that the same mistake are repeated. The people who know us know that other topic or instrument which we are very often using are Inspire hackathons. These are now mainly virtual hackathons, and we are organizing this twice per year in Europe. In Africa, we organize also one in South America, and we are trying to bring the results from previous project and to show how it could be reused. And in reality, a lot of research which I will present today was also the part of this Inspire hackathon. I mentioned that in 2015, Plan for All was established by 3 organizations. Now we have 60 members in Europe, Africa, and America, and we hope that we will continue in some grow, and that we will be able to build strong international network. Second organization is Wirelessinfo. It is private research, and also this organization was in some way as a result of previous project. It was in reality the first European project which was coordinated by Czech coordinator, and the focus is mainly on ICT for agriculture. This is the main focus, and Wirelessinfo is working about this long time. Now, why we want to use the time series? Yes, there are 2 very important topics which can lead to this decision. One is that different crops has the different phenology, and sometimes it's very difficult to make some division among the different type of crops in one date. But if you are using the time series starting from the beginning of the season till end of the season, you are very well able to detect different type of the crops. And of course, it is very easy also to detect urban areas or other abiotics objects, because this object has stable reflectance. There are not such changes like in crops. Yes, and every crop has different phenology cycles, and this is the key topic what we recognize that is important for this increasing accuracy of classification, and so we start to make some large experiment using this time series. Second topic is why to work with Sentinel-1 images. What is the big problem of Sentinel-2 but also Landsat data is that very often the data are not available due to the clouds. Yes, it could happen that you have more than half of season without any data, and the result from year 2020 is not so bad like from this year in our country, because from this spring there is only few images from Sentinel-2, and it is difficult to provide some analysis only on the base of Sentinel-2. I will show later that the processing of Sentinel-1 is not such easy like processing of Sentinel-2, but there are possibility how you can increase the accuracy and how you can receive the better result, mainly for crop detection. So this was the reason for our research, and we ran a number number of experimentation, and we also tested and tried to compare supervised and unsupervised classification. Both from these two type of classification has some advantages and disadvantages. The big advantage of supervised classification is that you are able to compare accuracy of the data, that you are in some way managing the result. You are able to select what you want. On other side, what could happen if you don't have the good training sets and some type of land cover is missing, then could be errors in the classification. About unsupervised classification, you don't need to have any training sets. Yes, and the classes are divided on the base of similar spectrum, and the algorithm are selecting similar object, but what is making some cluster, but what is the disadvantage that you don't have direct interpretation of this data, because this division to the classes is done by algorithm, and also is difficult, for example, to make some testing, because without testing of testing sets, you can tell how is this accurate. What we are now trying is to go into steps. First, to start with unsupervised classification, and in second steps to move to supervised classification, and combine both these approaches to receive the data. We run a number of experiments with supervised and unsupervised classification in Czech and Slovakia. I will show also on the end some small pilot which we done also in Africa, and what we try also to work with the time series and using different indexes and compare the different indexes. We decided that if we will go with multi-temporal classification to reduce the number of incoming data, we will not use all the channels, but we will use through all season only some selected indexes, and with this we are reducing amount of the data which is used for classification. So we compare the accuracy and compare the methods of classification using different type of indexes from both from Sentinel-1 and Sentinel-2, eventually combining index from Sentinel-1 and Sentinel-2. Here you can see some result which we receive, and the images which are noisy are images where is used are used Sentinel-1 data. You can see that from this radar scanning, the data are much more noisy than the data which are coming from Sentinel-2, and you can see that the images where we are using this Sentinel-2 data, it is this image in the second line are in some way noisy, and that much better looks the data, for example, which are based only on classification of using, for example, this array index, then this looks much better. But later I will show you some way how we can overcome this problem. So this was one thing what we done in the Czech Republic was the comparison of different indexes, and also in using these indexes from different period of season. Yes, we tested, for example, to start only data from the beginning of the season, and then we add more and more time series, and we follow how this type of classification can be accurate. Other topics is, as I mentioned, that we use unsupervised classification. We make some tests with unsupervised classification in Slovakia, and also we tested what is better, yes, if to go with a limited number of classes or to go with higher number of classes. In reality, what we recognize as a good way could be to go with a higher number of classes in the first stage, and then these classified images to use for some type of supervised classification or classification of the objects. So this was other topic. Here you can see supervised classification from the Czech, and again you can see the difference between three images where we combine Sentinel-1 and Sentinel-2, and the images where was used only Sentinel-2. So this is in this case we can simply say that use only Sentinel-2 is better, but as I mentioned, it could happen that we will have no data, and then we need to look the way how we can increase the accuracy, or what we can do to have the better result. Here is also we try to compare different type of algorithms, yes, how different type of algorithms with the same set and same data can influence the accuracy of the classification. In reality, here we didn't see so big differences. I think that more important is, for example, to use the time series or to select the right channels. And here, what is very interesting is this statistic. As I mentioned, we start work from the beginning of the season, and you can see that the first classification was using only the data from March. The accuracy is very low for all combination of all channels, but if we continue month by month, we can recognize that already during the April we are able to have relatively good accuracy, which could be useful, for example, for some global assessment or for some statistical analysis of the market. And if we go till end of the season, the accuracy of classification is for some channels higher than 90%. So, but this time analysis we saw as very important, because we expected that using this time series from the beginning of the season and go could help us already in the middle of season to have already some statistic about areas of potential crop, and we can start to work with this. It could be useful for the food industry, but also eventually for some global initiatives to be able to monitor what happens. So here we see this usage of the time series as useful. You can see also that the data sets where Sentinel-1 was used, the accuracy is slower than the data when only Sentinel-2 was used. Also, if we combine both Sentinel-1 and Sentinel-2, the accuracy was lower than using only Sentinel-2. But this was in the year 2020, when we had enough Sentinel-2 data. But now I will go to the next image, and there is some other result. And what we start to do is to classify not pixels but objects. As in Czech, we have this land parcel information system, which is open. So this is in all European countries, and this could be some good base for some more accurate analysis. So we took these parcels from this land parcel information system, and we then make majority classification of every parcel and compare the result from different channels. And here we have two classification based on this majority classes. One is from SENTINEL-2 and second is from SENTINEL-1, and you can here simply see that the results are equal, as that the noise which you see in the pixel classification can be overcome with using this classification of the parcels. This method was partly built on some studies which was done, but we see this as some promising way to be able to work directly with the parcels, not only with the pixels, and this can be very useful. For example, in Europe, we have data for every country, this land parcel information system, so such method could be used not only for analysis of the areas of the crop, but also for the controlling mechanism and other. We was thinking in one hackathon how we can apply not so accurate, but in some way similar approach in Africa. Because usually there are no data in Africa, and we look on the possibility how we can work. And at first stage, we decided to build a new vector map, which is in some way combination of the data from global cover and the data from OpenStreetMap. And we, on the base of analysis and combination of these two data sets, we start to build a new vector data, which are more with smaller objects than are, for example, in global cover. And we generate this data set on the base of the combination of this data. Currently, we are working to build such map across all Africa. Now we have covered with this data 5 countries from East Africa, and then we start to classify this object on the base of unsupervised classification, because we don't have any samples for training, but this was really done in a very short period during one hackathon in 2 months. So we prepared this first attempt, but now we plan to extend this model and to work and to improve this model for all Africa, and to be able to use this data. Last thing, so what was our focus, because in some countries we had no access to land parcel information system, and we built objects directly from segmented images, and this is again from Slovakia, and we were able to detect well the single objects on the base of this time series, and this can help us then with classification, for example, for second year. So here we see also as the potential way to make unsupervised classification on the time series from one season, and then providing this segmentation of the images into the object. As I mentioned, we are working in more countries, and all this result can be seen on some hubs. We have the hub for Czech Republic, we have the hub for Slovakia, where we are working now with Slovak colleague, and also we are running some hub for Africa. All these experiments are published as open, and you can look on these hubs and you can see the result. And on the end, I would like to thanks to two projects which help us to finance this our work. One is the Smart Agri Hubs project, which is building innovation hub in Europe, and second project was EO for Agri, which had to define some vision for the future, how to use Earth observation in agriculture. So here is the contact to me, and I am ready for some potential questions. Thank you.
Thank you, Karel. Great presentation. Thanks. If people don't have questions, I will have one question. But first, let's see among the participants, if anybody wants to ask any question to Karel, you can either raise your hand or type your question in the chat box. And if nobody raises their hand, I will give you some more time to think of your questions. And in the meantime, I will ask one question to Karel. That's particularly interesting to me because I work a lot with data interoperability. And you said in your last slide that you have these portals which we can get the data. So how do you disseminate this data? Do you have data sets in different formats following, I guess, Open Geospatial Consortium standards? How do you disseminate the data?
Yes, on all these hubs, all data are described by metadata. So these are the standard ISO 19100, 15100, 19139, yes, standard. So you can discover this. They are described the accessing services. It could be WMS, WFS for this data. We are also a little extended the standard because in some cases for people it's easy not to work with these services, but we are working with map composition. If you remember some years ago there were introduced web map context in OGC, but it was not used so much. So we extended a little this model, and we are able to describe any map composition by some JSON format. And you can also share this map composition among, and for example, it is not only on our portal, but we developed some plugin for QGIS. And if you will implement this plugin, it is in QGIS repository into your QGIS application. You can then add the URL of the portal, and you can, or they are predefined, this URL of these different hubs, and you can also work very easy in your QGIS with any data which are on these hubs.
No, thank you.
So this is what about we are working, and if there will be some interest, of course we can share this more detailed information about this. But we are trying to make this, of course, due this interoperability, we are able to share this map composition or map among these different portals and other. Now for all this metadata or for this map composition, it is supported by this AHLS, NG, and the QGIS, but generally there is no problem. For example, this JSON, we already made some tests in the past to make similar implementation for a leaflet, or there will be possible to do this very easy. All is on GitHub, and all is open, so anybody can work, and we will be very happy. What we are also now trying together with partners from Latvia and Norway is to develop some, we are calling Google type work with the maps that we have. We develop collaborative environment that people are able to edit data from their own office on one server and do this parallelly like you are editing Google documents.
Great, thank you, Karel. Thanks a lot. We actually now have two questions. I will take first the question that was asked in the chat box because it was asked before. Is from Nitya, and the question is, do we have open source software libraries that can help in building crop detection algorithms? I mean something that may be generic, global, and can be fine-tuned for local crops and varieties?
I think that there are two things, yes. One thing is about the software packages. Currently, the most of software packages for analysis of satellite images are open sources. So there is no problem to select some software. There are also libraries for artificial intelligence. So about software is no problem. The more problem is to build some workflow or strategy how to analyze this data, yes, because there are implemented the generic algorithm, but you need then to prepare some customization. There are some softwares from ESA, European Space Agency, but usually there are also some predefined methods for classification, but it is usually only for European data, yes, or European conditions. So,
Okay.
so there exists really there is a huge number of different software, and if you will be interested, I can connect you with our colleague. But also, if you will be interested to make some tests. As I mentioned, we are running this regular hackathon. One is running now, it started, and you can find this on our Plan for All web pages. Yes, there is now, it is called AgriHub Hackathon, and there are two challenges. One is for classification of images, and second is for analyzing of the phenology. So if you will be interested, please join our team, and there will be chance, because this hackathon will run again something like 6 weeks, and there will be possibility to cooperate with the people and learn, because I think that it is more than to say that there is software. More important is to learn how to work with the data and what is possible.
One second before we go to the next questions. Veronica, I'm not sure if you want the webinar to last only 30 minutes. I don't know if you want to stop the recording and we go ahead with the questions, or we can continue recording. You decide.
Recording, we don't have any
okay.
The language.
Okay. Because now we have another question. We had two, but I don't see the first one. Noor, I think you canceled your question. You lowered your hand. Okay, so we can go ahead with Vaya. Do you want to ask a question? You can unmute yourself.
Hello.
Yeah.
Hello,
Thanks.
good morning. I am Wirelessinfo from Tunisia. I'm geospatial consultant at FAO. So thank you so much for your informative presentation. I have just one quick question. Are you planning to integrate, for example, a recent development with the world cover from ESA, just published last week? And as resources, you have the Sentinel toolbox, which is very helpful for processing all the data related to Sentinel. Second, are you aware of the FAO tools like CEPAL? It's a work environment that you can help and process data and also collect Earth. These are, I can share with you the links.
It will be nice.
Yes.
Yes, we know we tested the number of softwares. We are, I don't know about the newest version, but we are using the libraries from ESA, yes, but we are also testing other, and then we are testing also different algorithms of from artificial intelligence, yes. So this is important, and of course we are using also the data from FAO, and we are trying to combine this data. So in any case, we will be happy to exchange the information and start some collaboration.
Okay, thank you so much. Thanks so much. That's all for me. Thank you.
Thank you.
In any case, we discussed it before starting this webinar. Now there will be possibility also for collaboration between Europe and Africa in different horizon projects. So we are now ready, and this is our word cover. We don't have probably the latest data, but we are using this as the base for this open land use map for Africa. It is one from the layers which we are using.
Thank you, Karel. This is okay. Boya shared some resources in the chat, which I think will be useful also for the previous question. We have another question from the chat. Tool is asking, it's regarding the hubs that you shared before in your last slide. Could Mongolia join the hub? Is it open for all countries?
Generally, the hubs are open for all countries, but currently we have only data from Czech, Slovak, and for Africa. Yes, we are thinking to build in the future, for example, this open land use in the all world. But after Africa, we will go to build open land use for China due to the fact that we have now some project about harmonization data between Europe and China. But our dream is to cover all world, but of course, all depend on our resources and our capacities. Yes, but in any case, we are ready to share our experience and to help to the people to do this in their own. Yes, because we are ready to share the scripts how to combine this data and generate, because if there will be more people who can help us to generate these maps, it will be much easier. I have some good team around me, but it is limited, and of course also is depend on the financial resources which I have to my disposal in this moment.
Of course. So you mean that other countries could use your tools and your methodologies?
Yes.
And then they could send the data back to your portal. And they could...
Generally, if you saw these hubs, yes, all are based on the same technology, on the same libraries, and all are open sources. Of course, there is important how to integrate this, but we were able to build, for example, this hub for Slovakia in 2 or 3 weeks. Yes, there is most of the work is on the translation of the software and other, because we have the packages. It is possible to establish virtual servers and other. So in principle, it is possible. It is possible to do this in own. Of course, it is not very easy to guarantee the integration of all components. Yes, because these hubs are connecting QGIS, many components on the server, so we are able to tell how to synchronize, but it could take some problems. If you are using open sources, it doesn't mean that all will work very soon, easy together. Yes, to be able to combine different open sources together, it is something sometimes very challenging.
I understand. Yes. Thank you, Karel. I think, yeah, we have no more questions, so perhaps we can close the webinar. Again, this is the last webinar of the series. You've added the link in the chat to the whole series. We thank all the participants, and especially we thank Karel a lot for sharing all this knowledge. Thank you very much, Karel.
Thank you for the possibility to present our work, and I hope that we will have again soon a chance to meet each other on some IGAD meeting. Yes, I think when we met last time, I don't remember. It was Finland or after the...
I don't know, with IMA probably, with RDA, it was, I think, a few years, 3 years ago, perhaps. I was not there, but I think it was 3 years, I don't know.
I think that I was last time in Helsinki.
Could be. Let's hope, anyway, we all hope that we will meet again in person. Thank you very much.
Okay, thank you.
Goodbye, everybody.
Thank you.
Thank you.